Now let's make our animation a bit more interesting. Right now we have the linear animation, meaning every single point on our quad, on our plane, gets into its full screen position with the same speed as the other points and at the same moment. You could make it more interesting by changing the speed of the points, and so some of them arrive earlier than the others. And there are a couple of ways to do that, actually lots of ways to do that. The one that I like and the one I picked for this demo and the one I want to teach you is about corners, because this one is a bit different from the others and I think looks pretty cool. So let's try this one. First of all, I'll need more than one progress for this animation because we have 4 corners, so we could at least start with 2 corners. For that, I will add another uniform. Hue texture side, I'll add uniform corners. And let it be just 0, 0. So the default state is 0, the same way as the progress, it should be actually 0 by default. And so this is the starting position. Then to animate 2 numbers, it's better to use some animating engine, and I prefer the GSub. So I'm going to import GSub from GSub, and I'm going to create a simple timeline which animates 2 of those numbers to 1. So progress goes from 0 to 1. And that will represent 2 corners, or at this point 2 sides of the plane, left and right side. So let's do that. I'm going to create variable this tail GSub timeline. This creates a new timeline, meaning you can put as many twins as you can into this timeline. Then I could do something like this. It's going to be 2, and I'm going to be animating the uniforms. That's why you need uniforms, to animate them usually. Uniforms, hue corners, then value, and then we could animate X and Y of this 2-dimensional vector, hue corners. So I'm going to do this X to 1, and then the same twin for the Y. So it will start with X animating to 1, and then it will go to Y animating to 1 as well, one after the other. So not at the same speed. This is important. So now I have to declare this in my vertex shader. So I'm going to do just another uniform, hue corners, and how do we control this GSub animation? We have it, but it's better to have some control of it. We already have some progress here. So I could just tie that down to the same progress. To do that, we could just do something like this. So I'm going to comment the default hue progress, and what I'm going to do, I'm going to control the progress of my GSub timeline with this settings progress. So it's going to be this TL progress, and I'm going to set it right to this variable. And this means that the twin will go from, first the X will go to 1, and then the Y will go to 1 variable, my uniforms. So the twin is going to be played when I change this. So right now, if I refresh, shouldn't change anything because we don't yet use the hue corners variable anywhere in my code. So let's try to use it. Where do we use the actual progress? We only use it here. This is the line that changes the state of the animation. So instead of a hue progress, I need to somehow use corners. The corners is 2-dimensional, the progress is 1-dimensional. So this means that I need somehow to use, let's say I want to use the hue corners X here, just to check that. You see, when we only made the half of the animation, it's already in the end. That's because the second half is for the Y animation. And just to check things are working, the first half doesn't change anything, and then the Y goes to 1. All right, so how do we combine those two into one animation? There's one really simple one-liner to do that. So we can do the hue corners progress. It's not actually uniform, it's just the corners progress. And we're going to mix those two with the UV. As you remember, the UVs is the system of coordinates on my plane. And this system of coordinates goes from left to right, from 0 to 1, and from top to bottom also 1 to 0. So it's just the system of coordinates on my square, quad, plane, whatever, rectangle. And this means I could do something like this. So I could do the corners animation. So I could do the u corners x, u corners y, and mix them with the uv, let's say uvx, because we have the uv in both vuv here. So corners progress is going to be the float number, and this means when the uv is static, actually. Usually in mix function, this third variable is something that's changing with time, but not in this case. In this case, this is a static in terms of time, but these two are changing with time. So let's imagine for a second that both of those are 0. This means whatever the uvx is going to be 0 everywhere, and this means the progress, which I'm going to be using here, let's try to use it. This progress here is going to be 0 as well, so it's going to be the default state. Right, now let's imagine the end state. This means both u corner x and u corners y are 1. Again, regardless of the uvx value, it's going to be just the end state. But what's going to happen in the middle? So if you try to imagine that uvx is 1, this means when uvx is 0, part of the plane is going to be at the final state already, but not the right part of the plane, only the left part of the plane. Now let's see what's this, just as this one-liner, I took some time to explain it, hopefully understandable, what this actually does. You could see that when I played animation, the first half of the animation, just the left side went exactly to the full screen position, exactly to the points where it needs to be. And now when I play the second part, it just goes right to this to this position. So it's just perfectly fit into plane, regardless of the sizes of the transformations that we applied. And I consider this kind of magic personally, because this is really that simple and it gives you such a tremendous result. Of course, those two animations right now playing one after another, but we could just stagger them a little, so one starts to play right after the first one started to play as well. So it's going to be real cool. And the other thing that we can do here, not only we can do the sides of the actual plane, but we can do the corners of the actual plane. For that, the one-liner is going to be a little bit more complicated, but it's exactly the same approach. So I'm just going to change this one-liner to something a bit more complicated. And this means when we need to animate not 2 sides, but 4 corners, we would need to change the dimensions of these u corners. It's going to be 4-dimensional thing now. And let's also change the timeline. It's going to be z, and it's going to be w. The last one is a w. And then we need to change it here. So it's 4 zeros, which they represent now the starting point of the animation. And we have the timeline. Seems good. So now when I animate, it's going to go first quarter, it's already there, which is correct, because we have 4 twins inside our timeline. And then what we could do next, we should actually implement the final mixing of those variables. So for that, I will do 2 mixes and mix them together. So we're going to have 3 mixers. So first of all, it's going to be a mix of 2 mixes. I'm going to change those mixes with the UVY. So I'm going to change the corners now, but the idea here is again exactly the same approach, which we translate not to the horizontal scale, but also to the vertical scale, because you could see the similarity, because with this mix that we used for the sides of the animation, it's again the same mix which we're using for the top and bottom side of the animation. But here we would need X, Y, and Z, W. Let's see what's going to happen now. Let's try to play our animation. I guess I made some mistake. Yeah. Let's try to play it. So now you could see the first, it's animating one corner, then the second corner, then the other one, and then the other one. Isn't that cool? I mean, it's pretty simple math. Don't get me wrong, it's kind of hard to understand this one at the first glance, and I advise you to take some time to experiment, maybe change these corners and see what's going to happen, maybe put some other values there. But I mean, the idea of animating this plane to the full screen with just this mixed formula is just amazing. Now we have this. Now let's try to make it a bit more dynamic, and for this I'm going to change the actual timeline. I didn't have any duration there, and the duration actually doesn't really matter in this case because we are playing it with the progress bar anyway, but the duration matters when it creates this one single timeline out of 4 twins. So let's say the duration is 1, but the start of the second twin would be something like 0.2, 0.4, 0.6. And now they start to play a lot faster. So when the first corner still is not in this place, the others are already playing. Maybe we could start even earlier than that, something like this. Yeah, and you can change the orders. Maybe you prefer the left corner to go first, but that we will need to change the order here. So meaning the X, Y, and Z, you're just gonna mix them up. For example, right now, take a note, the first is animating the left bottom and then the left top. If we just change the order of these, oops, we're going to get the different order, which might be more suitable for your particular animation. And of course, you could put some other functions there, and let's try to make it even more interesting. Maybe put some more spicy things into this animation. Let's see what we can do. Let's make it even more interesting. First of all, I'm going to remove the rotation here, because I think the animation looks pretty cool even without the rotation. Those corners distorting and animating shape to the full screen. And then let's try to add some waves. How would you add some waves? I'll just bring back the old form of the animation here, and yeah, it's pretty cool. With the easiness, it looks even nicer than the linearly just dragging the slider. And then instead of corner progress, I'm gonna just put the U progress again. So now it's again linear, but let's add some spicy things to this one. All right, first of all, I want to add some waves. I have the time also here. Let's update the time. So, oh, it's already updating. So I could add some waves to my animation. Let's do that. I'm gonna do that in vertex shader, and first of all, I'm gonna do something like plot waves equals as we already experimented with the length of the UVs or the length of the position, we could achieve some waves and some circular waves with just taking the length of some vectors. So because I already have the UVs here, I could do something like this. So length of UV, this is going to be some circular kind of value. And I could take the sine function out of this one. Right? This way I would get something circular. And because this value is quite small, because the whole plane is from 0 to 1, I will need to multiply this one, let's say 5. And now how do we use this way? So now we have some number that is kind of sine function number, which we don't really apply anywhere. What we could do here, we could just add this wave distortion to the actual progress. So we could just add waves to the progress. But because the waves now between -1 and 1, this is quite big, and U progress is just between 0 and 1, probably we'll need to multiply this one with something small, because otherwise we'll get something like this, really distorted shape. All right, so let me multiply it with 0.1. We are getting some waves, but the animation is not animating like to the end, right? And it's starting distorted. To fix that, we'll need some variable that in the starting point of the animation is 0, and in the end point of the animation is also 0. And finally, the sine function is actually the most useful and the most simple way to achieve that. If you look at the sine function, it starts from 0 and it's 0 in 0 point. Then it gets to 1 point at pi divided by 2, and then at point pi it gets to 0 again. So we could actually get some, how would we call it, plot sine equals the sine of the pi, and let's quickly declare the pi variable, because I know what the pi is. You just do it right here. And then the pi multiplied with the u progress. And this means when the u progress is 0, this one's going to be 0. And when the u progress is 1, it's going to be 0 too. So we could multiply this with sine. And now it starts no distortion. When we animate, it distorts and then it distorts back again. So now what's left to do is actually to add some time here. So when we take the sine function, we could add some time, or maybe we could actually use the u progress itself, because we don't really need the time because u progress is running too. So let's see what's going to happen now. Waves are moving, but not as fast as I would expect them. Let's multiply this one with 5 as well. Now it's starting to look much more fun. So you could put some wave which is coming from, at this moment, it's coming from one of the corners of the plane. And we could even make those waves more, like maybe 15, 3 times more waves. It depends on the speed of your animation and the effect you would like to achieve. But I just wanted to outline the principle that you could use. So you could distort the speed of the animation depending on the position of the particles. So we used that to distort the speed of the corners, like so corners would animate one by one. But we could also use it to distort like the middle points, any kind of distortion. You could put the noise here, so it's randomly kind of getting to the full screen. You could also use, well, almost anything you could imagine. So it's an open field for experimentation. Of course, I will show you and share this code how to achieve exactly this kind of animation with you, but I would recommend you to try and play yourself to achieve something really unique, something nobody ever seen, and to use it on your website, because this is pretty cool. And the coolest thing about it is an experimentation. So yeah, this is this effect, and now let's try to use this one with the HTML. So enough with the shaders and preparation and all the basic stuff. Let's try to use it on the actual kind of production-like website, a small simple portfolio, and about that in the next section. So let's use our WebGL and shader magic and animation in the real life HTML. Like, let's imagine that we have the static HTML page with images and CSS, now JavaScript, and want to integrate our WebGL effect with full screen zoom into the real life page. Let's try to do that. So I coded a simple page. So far we have this animation, and I coded a simple static HTML page resembling some kind of portfolio or generic cases image, I don't know, maybe news, something like that, just a horizontal slider with something. I put the test textures there just so during the development we would always see how the proportions and aspect ratios are changing of all the images. So let's try to implement our WebGL into this page. We would also need to implement the custom scroll here, because you need custom scroll when you want to integrate WebGL and HTML, just so you would have the full control and you can keep in sync both of those worlds, both of those renderers, browser renderer and the canvas renderer. All right, so let's start. I have a separate folder, I called it HTML. It's just in HTML, just what it says, no JavaScript. Have it open here in the parcel. So I think the way to go here is to copy the JavaScript into the HTML. I think it's easier this way, because right now the only HTML that we have in the current demo is this, just 2 HTML elements in the body. And let's open the second project, the HTML project. So here in HTML we have a little bit more, not much of a code, actually it's just 60 lines. Just some list of items with the title and image, and I put some class here because we're going to be replacing those images pretty soon, and some custom fonts just so it looks a bit nicer. So I have this project running already in the parcel server, so we can go ahead and copy things from the previous project with the WebGL demo into this one. So first of all, I'm going to copy the elements that I need, like the container and the app.js, and I'll put the app.js into the JavaScript folder. All right, and then I copy the actual files. So I need the JavaScript file. I need to copy it right here into the JavaScript folder, and then the shaders as well. And then I'll probably need to change path to the shaders inside the shader and JavaScript to the texture, because I have the texture here. The texture now is in the folder image. So now I think I'm ready to save the app.js. I'm ready to save this one. This is all the HTML project now. And here we go. So we have the page which scrolls. I also added a simple CSS here. And the most important part here is that I have added this JavaScript here. So I put my container with canvas as a position fixed element, so it's always on the screen. And I put it with the z index -1. So this canvas element is always behind all the content on the web page. But the background of the body is black. So this canvas element, which stays behind and which still has this animation and progress bar, it's right between the body background and the actual HTML of the web page. So this thing is still scrolling. So we kind of merged two worlds together. The scroll is still native scroll, but we're going to change that soon. So this is the first step. We merged two worlds. So let's add the custom scroll right away. I'm going to close the old project. I'm going to keep working in the new one where the HTML and styles are. And let's add the custom scroll. So we have the app JavaScript here, and the scroll I would like to add is called S scroll. Well, no pun intended. Yeah, it's called the S scroll, and well, the logo is all right. And then why I like this scroll. We will learn about that a bit later. The most popular right now scroll for the awards websites and for the promo websites is the locomotive scroll, which lacks one essential feature. You can't control the request animation frame loop of the locomotive scroll yourself, so it's hidden inside the library. The only difference, well, the main crucial difference of the S scroll compared to the locomotive scroll, that you can actually control rough right here. So you can use external rough usage, as you can see here. So you can disable internal request animation frame in this library and use external one. And otherwise, this scroll is, I think, pretty cool. It achieves this goal of the smooth virtual scroll, and it solves the issues where you need to stay in sync between two worlds, because sometimes you just need the custom scroll. All right, people love it. Not everybody, obviously, but yeah. So let's use the virtual scroll. First of all, we'll need to copy the dependency, and then we just need to run it. So to run it, I will introduce new variable. This scroll equals new scroll, and then just enable it. There's one catch though, because the scroll is horizontal, and by default all the scrolls are vertical, obviously. I'll need to set another attribute, horizontal scroll true, when I enable the scroll. Let's see what's going to happen now. So it's actually working. I don't know if you can feel it in the video, but the scroll is smooth now, and we can see that the actual transformation is being applied to the scroll wrap. You can see that it's just transforming the scroll wrap, and we have the horizontal scroll, horizontal custom scroll on our web page. We still have the WebGL animation on the background working. Those two worlds still not quite connected, but we're gonna do that pretty soon. So let's do that. So now let's merge WebGL and HTML even closer to each other. So right now we have just the canvas on the background and those images. We need to somehow merge them so each image is in the WebGL actually. I even set the transparency to each of the images just so we would see immediately when something in the WebGL happens. I have the item image and I set transparency to 0.1 so we can barely see the HTML images. So we wouldn't need them anymore. Next, I want to switch the sizing technique that I'm using at the moment You remember we switched, we did the size sync, so 300 units in plain buffer geometry is actually 300 pixels in HTML. That's okay. But it's kind of hard to change the geometry size if you created it. So let's say I resized the web page and I want to change something. It's going to be hard to change the geometry to the other size. So it's actually better to use one by one geometry. And once we do that, we wouldn't be able to see it's going to be just 1 pixel because it's going to be just 1 by 1 and 1 is a pixel. But then after I create this mesh, I'm going to scale it. So it's going to be mesh, scale, set 300, 300, and 1. On the z-axis, it's going to be just 1, stays the same. And we can see the mesh again. So it's working the same way. Right now, if I scale, like move the progress of my animation, it's going to just go back to the center. And that's because when I did those calculations to the full screen state, I thought that the quad size was like some value. Right now it's just 1, so I can remove this part because it's 1 by 1, and the size, like the multiplication, I mean the scale that I need to apply to it is equal to the actual viewport size, which is your resolution. So right now it works properly. So just 2 slight changes and we can use the geometry 1 by 1 and just scale it whenever we like it. All right, so far so good. And one slight thing that I forgot to do in the previous videos, when we do the corners progress, we actually have this varying V size, which is responsible for the UV size. And right now the UV is not square anymore. So to do it square, we just set the corner progress here as well. And now you would see that it's going to cut a little bit. It's going to cut texture a little bit. Oh, my browser turns out to be almost square anyway. But now you would see it's actually scaling texture when it's zooming. So it stays with the correct aspect ratio and doesn't really scale. All right. Next, we are ready to convert all the images to the actual WebGL. This I'm gonna do this images array. It's gonna be document, query selector. And then JS image, because I set the class to each image to the JS image. Because this is not an array by default, this is a node list. I will need to convert this one to the array. The spread operator. Okay. There we go, we have it. Now I'll create another object which is going to represent all the meshes in my WebGL scene and all the properties that I need to know about them, like the sizing, the positions, and so forth. Because I will need to position each mesh on the place to replace it to the image. So I'm going to call it image store, and it's going to be this images map. And then I'm going to iterate through all the images. Just going to console log for now. Everything is working properly. It's always nice to check. And yeah, we have all the images that I have in my HTML. Working good so far. Now, I need to create a separate mesh for each of the images. And of course, this one will need the material and the geometry. So the material, it's going to be equal this material clone. So I'm going to just clone the default material that I have here. All right, for the geometry, I will create another geometry, like this plain buffer geometry, or I can just use this geometry. So I already have it. All right, and in the end, I will need to create mesh, which is going to be equal new 3 mesh, this geometry, and M, which is material, short for material. And then in the end, because this is a mapping into the array, I need to create another array and I need to return something in the end. I'll return all the properties that I need to know about this object that I just created. So first of all, I'm going to return the actual image. So I'm going to have the reference for the image. Then I can return the mesh, which is going to be the mesh. And I could also return the geometry, because later on we will need to scale this geometry. So when the browser is scaled, we need to scale geometry as well. So probably Oh no, we actually don't need the geometry because we will scale the mesh. We can scale the mesh. Perfect. And I will remove the old mesh, by the way. I don't need it anymore. So there's nothing bothering us in my scene. So we have mesh and we have image. Now we need to get some dimensions of this thing, right? And we also need to set some correct uniforms, because remember, in my uniforms, I actually set the texture size, also set the U resolution, and watt size. I will need all of those to set in my loop. So first of all, I'm going to get the texture. So the texture is going to be equal new 3 texture image, just like that. In Three.js, you can create textures out of DOM elements. And then, because this texture needs to be updated, it's nice to set needs update true, because otherwise the texture wouldn't be updated and you wouldn't see anything in your browser. So sometimes you need to set these values here. Right, now we need to get the sizing. To get the sizing, we'll just get the bounds variable. Bounds equals image get bounding client rect. This will return us all the needed information about the sizing of the object. This is bounds. Let's see. Say object DOM rect, and we have the bottom, the height, the left, the width. So we have all the coordinates that we need. And I can calculate everything that I need to. So I will just get I need the top and left position to position correctly the mesh, and also need the width and the height. So the width is going to be just bounds width. The height is going to be bounds height. Then the top and the left is going to be same. So now we have this image store object, which is an array. I mean, we have an array image store. Every single item of it is an object which has all the information that I need. It has the mesh, the image, the width, the height. I also need the array of materials. So I think I will create an array of materials. So it will be useful later on. So these materials is going to be just an array. And I'm going to push these materials, push my newly created material here, PM material. Now I need to set some uniforms to this material as well, just so it works properly. First of all, I need to set the texture. So because I have the U texture uniform, I will just do that. So M uniforms U texture value equals texture, my newly created texture. Remove the console log now. So now each of those has the texture. I can also immediately add all of those meshes to my scene. So this scene add mesh. I also need to scale those meshes because geometry at the moment is just 1 by 1. So I need to scale the mesh so it has some sizes. And I have the height and the width of the mesh already. So it's going to be this mesh scale set, and then bounds width, bounds height, and 1. This should probably scale the mesh to correct size and put them in the middle of my screen, hopefully. Don't yet see anything. This mesh, which is non-existent, I should just scale the actual mesh. And now we see our objects. Even though we see one object, because they are all of the same size, it's actually all the images that I had in my HTML stacked on top of each other. So now we have all the information to position those images as well. And the only thing left is to actually position them. Let's do that. So let's sync two worlds finally. Now we have all the dimensions, and we just need to implement them in some function which sets all the position. Let's call this function this set position, and then because we need to change the positions of all the elements inside request animation frame loop. Because once the user scrolls or something changes, we need to change all the positions. So now we need to actually change them. We will loop this image store. And for each object inside of it, let's call it object, we're going to change the mesh position. So we have the O mesh position X equals something, and we have the same position for the Y. So right now nothing's going to change, the mesh stays in center. Now this is a bit tricky moment. We have two coordinate systems at the moment. One coordinate system is the one that we have with the get bound in client rect, because this one goes from the left top corner of the viewport and goes down and right. This is kind of intuitive, right? In the browser, you measure from the left top corner. Now we have another system of coordinates, WebGL system of coordinates. Now, when we set something to 0 point, it's actually the center of the screen. And then the positive direction of the y-axis goes to the top instead of going to the bottom like it goes in the browser. So they have the sign difference. With the x-axis, it's actually the same. And now there's another slight difference. When we get the bound position of the DOM element, we get the left top corner position of the element. Now, when we get position in the WebGL world, we actually get the center, the position of the center of the object. Now, this is another difference. And this difference actually produces us quite, it's a simple and complicated formula at the same time. So as already told you, the x stays the same direction, the y should change direction. And we could set the position x of the mesh to the all left, which we already have. This is not going to be enough because this is going to be some distorted position, not accounting for the mesh size and not accounting for the coordinate shift. Coordinate system shift is actually half of the viewport browser, half of the x and half of the y. So we have to add, we have to subtract half of the width. Half of the width is actually this width divided by 2. And now we should see something. Now we see the objects, they are roughly positioned almost at the point that we need them to be, but they are still shifted. And they are shifted exactly the half of the distance they need to be. And also I think because we're moving this thing and the position is taken only at the beginning, it's a bit off. But then we need to add half of the width of the actual mesh. So it's going to be O and the bound width. That accounts for the difference in coordinates, like the left corner or the center in WebGL. Left corner in DOM, center in the WebGL. And this should get us the correct results, but I think the S scroll it starts in some position. You could see that it starts in correct position, but then it moves a little bit. And because we are not yet accounting for any scrolls, the position is a bit off. But you could see that the start is correct one. Now we have to implement the same formula for the y coordinate system. Now, first of all, it's going to be minus O top, because the difference in directions of the system of coordinates, and then we have to add half of the height, and then also subtract, so all the signs are different, subtract half of the height of the element. And now you could see that it actually starts at the same correct position. So the spacing between the elements is correct and it starts at the same position. So the only thing left is to account for an actual scroll position. And this is actually not that hard. So inside the set position thing, I could just console log for a moment the S scroll. Let's see what this object has for us. So inside this object, we already have some values. And one of the most important ones is the current position of the scroll. Which one? The one that is changing all the time. So let's see it for a second. So it's updating all the time. Now it's 0. And when I scroll elements, it's changing. So now, because I have the horizontal scroll, I only need to change something about the horizontal position. So I could just maybe put this value right there, because I should change the position of the elements exactly as the scroll changes. See what's going to happen. You'll already see that direction is off, so it's got to be with a minus. And now magically we have the same scroll, the custom S scroll, but now all those elements are actually WebGL elements. And you could we could change something here, just output UVs, for example, just to see that those are actually WebGL elements. We still see the semi-transparent DOM element over those WebGL elements because WebGL canvas is behind the HTML. But we can see the UVs of the WebGL meshes now. So we successfully converted and merged WebGL and HTML worlds now, and we can actually apply some zoom effects and do the resize part, because right now if I do the resizing, it's gonna break. Just see it. So I just resized elements and you can see that they are off, the scroll is off, it doesn't work properly. So let's do the proper resize and then continue with the animation and implement some transitions. So now let's implement the resizing, because it might seem a little bit tricky because we have the HTML, we have the WebGL, they are somehow in sync, and then you resize and everything breaks. First of all, I have the field of vision, which is the sync part, where we sync the dimensions of the WebGL and HTML. So I should update that first, because the height of the browser could change and we will need to update the file. Now the next part, you remember that each of the materials has actually U resolution part here, which contains the size of the screen. So I need to update that as well. So I could iterate all the materials because I already have the array for those. It's called these materials. I'll put definition at the top. So inside the resize function, I'm going to go these materials for each material and then update the uniforms. So it's going to be a material, uniforms, U resolution, value X equals this width, and the same for Y. This will be needed for the animation because we are using that U resolution part for the full screen part of the shader. Now, the actual positioning of the meshes and their size is inside image store array, this one. So we need to update that one, and then the function set position will immediately take the correct values and should position the meshes correctly, hopefully. So let's do that. So I'm going to iterate this image store inside my resize function. And for each item, I'm going to change some values. First of all, I'm going to recalculate the bounds. So the bounds is going to be equal image get bounding client rect. So these are the updated sizes of the DOM element that represents this mesh. Now you see why we needed those DOM element in this image store, just to get the new sizes again, not to iterate some random images. Then I need to scale my mesh according to those new sizes. So mesh scale, and now the mesh is useful now. Scale set, and we're going to use the bounds width and the bounds height. And the Z is going to be 1 scale. So this way we scaled every image to the correct size. It's much easier now because we're using scale, not the geometry size. That's why we changed it to 1:1 geometry, so we could just set any scale and the mesh would change its size. So now I will need to update the top, the bottom, the left, and all the attributes that I had for each of those items. So top is going to be bounds top, left is going to be bounds left. But there's a trick about the left, because we have horizontal scroll, and if we resize and the position was not 0, we need to account for the current scroll. But let's do it in a second. Also update width. And the height. So we updated all the things, and now we also need to update the size of the mesh. We actually had two values representing the size, like both the texture size and the quad size. In this case, they are the same because I'm using images from the HTML, and obviously the size of the image is the size of the image, but then it's also the visible size of the image. That might not be the case in your project because sometimes you use background size cover or some contain or something like that. So the image covers something. In my case, it's going to be the same, and I'm going to set both view quad size and both view texture size to the same values. And I'm going to do it here. So it's going to be mesh material, uniforms, view quad size, value x equals bounds width, and then y bounds height, and then same goes to for the other value. I actually need to set them also in the creation of them, but I don't need to because I have the resize function running at the start of my animation, and this function will set all the sizing correctly. Yeah, so I could even run this function maybe after, because I have it. So after I edit all the objects, I will just update every single one of them. All right, and now I have the sizes, not the uquad size, but the utexture size. Everything's still working properly, and the resize should be actually working. Let's try the resize now. It's working all right. So all the meshes scaled down, and the size of the mesh is in style CSS. And at the moment, I set them to the 30 viewport width, just so I'm dependent on the screen size. So when I resize, it's actually working, but I resized when the scroll was 0. Let's try to resize when the scroll is not 0. See what's going to happen. You can see the mesh side is kind of correct, but then the position is not correct at all. So they moved, and the last one is missing because it's probably moved to the left. Yeah. So we have this slight shift. And this is exactly the reason I told you about the left position, because it needs to account for the scroll position. So inside this left, I just need to add this as scroll current pos. See what's going to happen now. So I scroll some width, I resize, and it stays exactly where it needs to be. You see? So we actually successfully implemented the resize function. There's also one thing, it's hard to see this one on the video probably, but there's slight delay sometimes between the WebGL world and the HTML world. WebGL world is actually these UVs now that we see, and HTML are those titles. And sometimes they are just one pixel behind. To fix that, we need to implement the feature of the scroll, and this feature is called disable ref, which is disable default request animation frame loop, and it needs to be in the parameters when I initialize the scroll. So let's do that. It's going to be disable ref true. Now, if I go back here, the scroll doesn't work. I'm trying to scroll right now, but it doesn't work. This means when we disable the scroll, we need to update scroll manually. And this is where we can control fully, like when to update scroll, when to stop updating scroll. This is the good thing, the very good thing about the scroll. So here I need to update scroll. It's going to be this as scroll update. They have this method, scroll update, called the internal animation frame request callback. This is exactly what we need. So now both the WebGL world, it's being updated here in set position, and both the scroll are being updated in the same request animation frame loop. Not only they are in sync now, but it's also better for performance of the web page to have just one request animation frame loop. Let's just check if everything working properly. Yeah, the scroll now works. The resizing part works. We actually have a pretty cool web page at the moment, and I can switch back the textures. And yoo-hoo, we have the web page with the resize and with the WebGL world. And now we can finally start to implement some cool animations and take advantage of the WebGL layer that we have here. Now let's have some fun and implement the animation that we created in the WebGL part, the zoom into full screen animation, now to the actual images. how it's going to happen. We will need to use this timeline, and we will need to get rid of this progress now. We don't actually need those settings, and just not the setup resize, but the setup settings. Yeah, and I need to remove also the reference to those, like this timeline progress. Now it's still working properly. I got rid of it. And then inside this array, when we postage rate over all those images that we converted to the WebGL, we have the actual image, and I can add an actual event listener to the DOM image, because the DOM layer is actually over the WebGL. It's going to be image add event listener, let's say mouse over, and then some event handler. And here I will just copy the timeline that I have. Probably needs to run a little bit faster than now, because 1 second for each animation is too much. Let's say 0.4. Also, it's not this material anymore, it's just the M or material. Right. Now let's see what's going to happen. When I mouse over the image, we see the magic. Let's also implement the mouse out animation, because it just goes one way. Mouse out, and then all those values to 0. Now let's see. The mouse out, it goes back. That's pretty cool, I should say. There's still some bugs, and if you go immediately from one to the other, it's actually working pretty cool. You don't actually need to fix anything. It's working good so far. Now, the other thing that we might want to fix here, when one of the planes goes for the full screen, we might want to make it like over the others. And for this, I just need to change the Z coordinate inside my vertex shader. So when I do the final state thing, I could just use, for example, the U corners X, for example. So when the U corners X is over the 0, just a little bit over the 0, I could move my whole plane a bit closer to the camera. It's going to be Z plus U corner X. Now the plane that goes to the full screen always covers all the others. Isn't that cool? That's pretty cool, I should say. And then that's already a cool demo that we might want to play. And whenever the plane is, remember how we fought the war on shaders and achieved this effect, so that any plane from any size of the from any position on the screen goes right to the center, to the full screen, and the texture is scaled correctly. You could see that it's just a little bit cut because my screen is not square, but it still preserves the size of the texture, and it's perfect. So now we are ready to actually implement the page transitions and do this transition to the other page, because right now you could see that this goes to the full screen. If I click, it's the same image, but now we have the vertical scroll and some other page. I also coded a simple static HTML page for the inside page, so we can illustrate this transition from the WebGL page with the custom scroll to the other page with also the custom scroll, and possibly WebGL, you could add anything to it. So let's continue and implement those transitions. Now let's implement smooth page transitions. They could be implemented with frameworks like React, Vue, but if you're using vanilla JavaScript, and in a lot of cases you just don't need some features from React, and you're using vanilla JavaScript, that's where the Barber comes in. And you can use Barber.js to implement smooth page transitions without using some single page frameworks. So how does Barber work? If you go to the home page of Barber and click, for example, on features, notice the URL. The URL is going to change. And there was a smooth page transition, just the animation happened and the URL changed. And then I click again, the URL changed again, and you can see some showcase of the coolest websites using Barber.js, and I really recommend looking into them to see what is possible with Barber.js. What transitions could be done with Barber.js, how creative you could be with it. And on my side, on the editor, I have two pages coded. One of the pages is a WebGL demo with elements combined with the DOM elements combined with the WebGL meshes. And then there's the other page. If I click on this one, the page just has the some text and the image on top with the CSS background size cover, just like that. And when I go between the pages, you could see that there's a loading indicator, which means that there is no smooth transition at the moment. So let's try to implement Barba on our web page. First of all, we go to the documentation, there's an install page, and on the install page, we need to do the npm install and then include the dependency. So if I go to the app JavaScript, you could see that I already put the dependency right here. And now I could run Barba initialize. So this is the way to run Barba. So I'm gonna go here and create another this Barba method and then run Barba. So Barba, I'm running Barba initialize and then I have the Barba, should be working. That's not it, of course. We have to also change some HTML for it to work properly. So we have to wrap the part of the web page that's going to change inside two elements. Let's do that. In the example, there's body and main. I should probably just use two div elements because I already have body. This one's going to be body. I have some helpful comments there describing like what those elements actually mean, like whether you need wrapper or container. And then two closing divs and Barba. It's nice to put those comments because once the formatting got lost in some of the fixes, it's going to be easier to find the end of the div. And then I'm going to do the same with my inside page. The inside page is pretty simple itself. I also have the scroll wrapper here, and it's just the single page with some texts and some footer. So let's wrap it inside two divs. Gonna be the wrapper and then two closing divs, just right after the scroll. Right, so now we have those elements. I'll just check whether I have Barba in place. Yes, I do. Do I run Barba method on start? Yep. And initialize Barba with an empty object. Now let's try to click the element. And you could see there were no loading indicator, and I got immediately to the page. Even though there's just simple static pages, but still, before Barba initialization, I had some loading, some slight blink or delay between them. Right now, they're just smoothly transitioned from one to the other. I'm going to refresh it again. I'm going to click. The web page changed, but I'm still on the same website. So right now we implemented the simple Barba transition, but let's add some animation to it. Let's make it an animated transition between those two pages. Let's implement a bit more complex smooth page transitions with Barba.js, because right now we have an immediate transition. So the way to do that is to look at the Barba documentation and see how they implement that. I'll just go ahead and copy the code and explain it a little bit. So we have two methods here, leave and enter two functions. First, the leave function is being run, obviously, when the content needs to hide the old container, and then the new content should appear with an enter function. Both of those functions expect to return something like a promise, something with fulfilled state, because the next function is run right after the other, so it's got to be some kind of promise. The good news is that gsub supports that, so if you just return gsub timeline inside of that function, it will work the same way. There's also a possibility to run leave and enter at the same time, because sometimes you need to animate like this, like slide them so they both animated on the screen at the same moment. And for this, there's a sync mode, and you just set sync true, and both of those animations will run at the same time. We don't need this for this particular animation, so we are fine. So let's see how to implement this. First of all, there is a small bug that we need to fix. Right now we are on index.html. If you go to the inside and we try to scroll, it doesn't scroll anymore. Even though they were just a few minutes ago, they were native scroll, vertical scroll, it doesn't scroll anymore. That happens because when we run the scroll, we only initialize it with the horizontal true rule. So it means it always tries to make a horizontal scroll. But on this page, it's a vertical scroll. So we need to distinguish between those two on the starting. And the way to do that, for example, is a class for body. So I can check whether the body has this class and decide what kind of scroll I should initialize. It's going to be inside. So instead of true, I would just go document body class list contains and then be inside. So if it contains be inside, it should be the vertical scroll. This means I should do this. Now I refresh this page, I see the vertical scroll and everything works good. And if I go to the home page, the horizontal scroll is working. Of course, the scroll doesn't work when I transition between pages, and that's what we gotta fix, and to add the transition as well. So let's try to do that. First of all, when we will try to do this animation, we will need to use GSub and control some DOM elements. But which DOM elements? Luckily, we have the data attribute. I can console log this one for a second, just to see what we have there. Let's click, and we see this object. So it has the current, it has the next, and the trigger. We are mostly interested in current and next, and specifically the containers, because those containers are actually what is being animated. If you remember, Barba is using two DOM elements. One is a wrapper and another is container. And the way the Barba works, once I click the link, Barba adds another container. So for some short period of time, we have two containers inside this wrapper. And then they're being animated, like the leave and the enter animation, and then the old container is being removed from the DOM, and we are left again with one container. That's how it works. So that's why we need this data object, because we can operate with those DOM elements and do something with them. And let's just do that. So I can do return gsub timeline and then animate something. So for example, I can animate here the whole container, data current, because this is the old container. And then let's say I want to animate opacity to 0. I will do the same in the enter animation. I'll remove the comments. Except that in this animation, the new container had to appear. So it's going to be data next, and then not to opacity 0, but from opacity 0. It means it will animate it from 0 to 1. Right, I made a mistake here. Double dot. And double dot here. Right, so now we're on the index HTML, and I go to the other page, and I just have the opacity animation. Of course, the canvas is not visible at the moment, but still, it works. So when I go to the other page, I have the animation being played, and now the scroll doesn't work because we only initialize a scroll on the startup of the web page. We don't reinitialize it when we switch from one page to the other. That we will just need to implement a little bit more complex animation, and let's see what we want to do here. Because right now we have two custom scrolls, one horizontal and one vertical scroll on two different pages. And I intentionally overcomplicated things a little bit. I could have stayed with just native scroll or both horizontal scrolls, but let's see how you would need to disable or remove some JavaScripts when you switch from one page to another when using Barba, because you would probably need to do that, to reinitialize event handlers or remove event handlers. And let's do that. First of all, we will need to reference some objects from my sketch sketch class. And because Barba already has this keyword, I would need to do something of this sort. Now, inside leave animation, the first thing I gotta do, I actually want to disable the scroll completely. So I'll do that as scroll disable. see what's going to happen now. So I'm moving from the home page. We're right now implementing only the home page to single page animation. Clicked it, and I have the native scroll right now. So as scroll doesn't work, I can feel it with my scroll bar, but there's still a canvas behind the DOM elements, and it's not quite working properly yet. So let's fix that. On the enter animation, we gotta change something too. Probably we need to reinitialize the new scroll just so it works on the new page as well. Let's try to do that. So first of all, I'm gonna initialize new scroll. Scroll, and then I need to put the options that I had for the old scroll. It's gonna be disable true because it's gonna work the same way. And then I need to state what's gonna be the container element. So in this particular case, it's better to state it because the new container element is being added to the DOM, and it's better to deliberately set this container element. So it's going to be container element, and then data next, because this is a div that's being added. Container query selector, and then how you would find it. It already has the data attribute as scroll container. This is the one. So this is the HTML that's going to be added inside the next container. It's already has a scroll container, so we can use this one. Right, and then we need to enable the scroll. And it should be enabled also with some options. So we could also set the scroll element there. And another thing that we need to fix, because we are going from the home page to the inside page, we actually need to state that the scroll is going to be vertical. But the vertical is a default scroll, so we can just omit the horizontal scroll value here and just do the new scroll elements. There's specific values that needs to be set, which element is going to be updated with a new style transform property. This one is going to be data next inner, same way. Scroll wrap, this is the element, this one. All right, seems good. Should be actually enough to see something. Let's try this transition from the home page to the inside page. This, and now the custom scroll works. We still see the DOM element, the canvas element behind it. So to fix that in this particular case, just hiding the canvas is enough because we don't have WebGL on the second page, at least for now. So it's going to be that container because we already have that element, style, display, none. Let's go back to the home page and let's try this transition. So it's zooming. Yep, it's working. So we just implemented the transition from the home page to the case or blog post or whatever this is going to be page with a full screen image. Perfect. How do we implement the other way around transition? So let's say we are already on the inside page and we're going to go back. I put the link on the logo. So if I click this one, going back, but we don't see canvas and the scroll doesn't work, so we need to implement this transition. How to do that? The way to go with this one is to use the so-called directional transitions or specific transitions set to be used when you go from one specific page to the other page. Now you have to notice that when we implemented Barba HTML, we used this data Barba namespace thing. So one is a home and the other one is the inside. So we could use those keywords to implement the transitions. And we can do this way. So here is going to be another property, which is going to be from, and then it's going to be namespace, and namespace should be an array, and it's going to be from home. So this transition now will be only used when you animate from home page to all the rest of the pages. So now we need to copy this transition and create another one that will be used when we will go from inside page to the home page, because those transitions are an array transition property is an array. This is just the first transition, and then I can just copy and create another one. All right, so now we have second transition, which is going to be from inside page transition. And here I will just put inside, and I'll change something, of course. And this one is going to be from home transition. And just to check that everything is working properly, I'm going to put some alerts from home, from inside, sorry. And here's from home. Let's check it. So we are on the home page. I'm clicking, I'm animating from home. That's correct. I'm on the inside page. I'm clicking and I'm animating from the inside page. So those settings are working perfectly. So this way you could do the complex connections relation between pages. So you could smoothly animate one into another, because some elements could be on the page, some elements could be missing on the page, and you need to account for that. So let's implement this animation too. First of all, we will need to remove those alerts because they're bothering me. And then this is the inside page animation. I removed the alert. All right. So this one is animations that we have to be working on. So there are a couple of ways to, a couple of creative ways to do this animation from the inside page to the home page. First, you can do it in a really complex way. So you can scale that down, zoom that plane down, and show the slider. You need to do a little bit more computations for that, and oftentimes websites avoid that, and they do a simplified transition between such pages just to avoid those complex computations, because somebody could resize during the animation, or there could be some complexity there. So, and usually the simple curtain animation is being used for this one, and let's just implement the curtain. So I'll need the div thing, which going to represent this curtain. I need to provide some CSS. So it's going to be just the full screen color div. And some background. Background could be, like, let's say we use this gray. So now it's just fully covering the web page, and I could apply some small transform. Not really small, because I'm gonna move it away from the screen, like 90%. It's gonna be at the bottom right now. And I could do 100%, so it's gonna be out of the viewport. All right, so we have the curtain thing, and now I could do this animation with a curtain. First, when we are leaving the web page, I could hide all the content with this curtain. So before moving the div to the opacity, I could just do another twin curtain, and then let's say duration something small, so it's going to be pretty fast. And I'm going to animate it to the Y0. And this means when I click here, it should cover all the visible area. So let's test that. Just covering all the visible area, I don't see anything. All right. So now I need to also remove this thing, right? And here I'm going to do the same too. On the enter animation, when the content already appeared or appearing, I will do Y minus 100%. So it means it goes all the way to the top, hiding from the viewport again. Let's see how this one works. So I'm clicking title of the project. It's hiding, removing, the content appearing. So it's looking pretty nice. We could actually even remove the opacity transition here, just showing the content. we don't yet see the canvas. And why is that? Because on the inside page, we don't really have any images that are moving to the WebGL. So on the start of the page, we don't add any objects to the WebGL. And we need to fix that on the enter animation, not just recreating the scroll things, but we also scroll is not working. That's because when we enable the scroll, we actually need to put the horizontal scroll through here. Because by default, this is vertical. So now if I go from the inside page to that page, the scroll is working, at least the scroll is working. So now we need to fix the missing WebGL object. And this is quite simple actually. We should just run the add objects method that we already have, which is gonna be taking all the images and creating meshes for each of the images and putting them right into the WebGL. And then also the resize function, because it sets all the uniforms for the zoom animation for each of the meshes. And that should be it actually. So let's try to animate again. So now we are on the inside page and I click the home page, hiding, it's showing, but then the canvas disappearing again. Why is that happening? Because I copied the full transition and I had this incomplete thing hiding the canvas, which I don't need anymore. So let's do that again. I'm on the home, I'm on the inside page. I'm clicking back to the home. And well, yeah, it's perfect now. So I can click again and go to the inside page. And this is how this works. So we just successfully implemented the full back and forth transitions. Not 100%, let's be honest, but let's just stop for a second and enjoy how cool is that. So we have the simple page and then we just do this, the curtain goes, no loading screen. You could do whatever animation you want. It might be SVG, might be a lot of curtains, whatever. It's just JSUP. The possibilities are endless. And then you're on the home page and I click and I go smoothly to the other page transition. Of course, those images would be different. Those are just for testing purposes for now. So it's pretty cool. What's missing here, if I go back and forth a couple of times, I would need to clean the meshes up, because right now I'm creating the meshes regardless of whether I had them or not before. So maybe just a simple flag should be enough. This is quite simple. And of course, on a real life website, it's going to be a little bit more complicated, because you might have more pages and some other pages might have those objects as well. So when I'm going to be leaving the web page, I'll probably will need not just disable the scroll, but also clean up all the WebGL elements or run the hiding animation for them, and then recreate them every time that I load the new web page, just like I did right here. So right now, if we go from the inside page to the home page, we're actually creating all those images while the smooth transition is happening. And this is also one of the reasons why you would want sometimes to postpone the transition so the images are loaded, because if you load the images into the WebGL and animate at the same time, there might be some stuttering, because this is a bit there's some performance needed to load images into the WebGL. So I don't recommend you doing the animation and loading some images into the WebGL at the same time. So you just want to wait. But there's lots of small things to do, because every award-winning website, trust me, this is a lot of work. It requires a lot of small details to be fixed, a lot of things to be covered. But we just did this transition and only those small things actually left. The big thing is ready. So let's move on and see how we could use this transition with the CMS. Now let's implement the simplest CMS possible to wrap our whole small website into something more structured. So what do we have now? We now have two pages, just the index HTML and index inside HTML, and we can move between them. I just added a couple of fixes just so I can move back and forth infinitely. I empty the image store array every time I go to the home page, and I recreate it again. Sometimes you might leave it in the HTML, because in my particular case, that canvas is always the same. It always has the same set of images, but I think it's more clean and I don't have to worry about recreating it again. I mean, doubling the number of meshes. So I'm just going to clean that up. And probably you might find this code useful, this snippet that I've added when you're going to do your websites. So just look at those methods. I'm not going to stop at this because it's not really interesting in terms of development. So I just rearranged and cleaned some objects. So we have those two pages and I can move between them. The animation is working. Everything is good. So now I need to use the CMS. 11T is not quite the CMS, it's actually a static site generator, but because it's so famous and the community is quite big, I mean relatively famous, and so many CMSs are now easily integrated with 11T. So if you know how to use 11T, you can then quite easily integrate it with some headless CMSs or with something like that, like even with Netlify CMS. 11T has a integration with a Netlify CMS, which is really cool because you can it's like everything in one place. The CMS you're using, the deployment process you're using, you can just do this in one place. So let's see how you can use the 11T. Well, first of all, of course, you can start from scratch, but I wouldn't recommend that because there are so many things that you need to have starting with 11T, much more than with 3JS. So I recommend you going and looking into the starter projects, and there are all sorts of starter projects, like the ones with the compilation with the headless CMS already integrated, or the ones with just nothing, even no CSS, just the HTML stuff. That's the one I really like because it's easy to convert your HTML, your markup into those kind of CMSs, which are really simple, bare bone. And the one that I like, I think, is the 11T block minimal. Even though it's block, we'll see that it's not really about block. So if I go to this project, this is going to be a repository. You can clone this one, and the website is really simple. So just a list of the posts, and then you click on the post and you can see the post just like that, just the simplest blog possible. But the content is stored inside the posts folder here and inside the markdown files, which is really cool. So it's like almost like a CMS. It's the simplest developers CMS because you're not hard coding anything, you're not using JSON, but the markdown is actually quite good format to use for the texts and for the data. Let's see how we could use this template and how it looks like and how we could integrate our HTML and our whole project in there. First things first, I'm going to take a look here. I removed the texture that I've been using because this is a hard-coded texture and I wouldn't be using it again. So no references to this one. Then I need to build the project because this 11T block template doesn't contain the build process, the bundler. So I just need to build my website. So I'm going to stop this one. I'm going to do parcel build index HTML. It's going to take some time, but it's going to build me JavaScript and HTML and CSS. I'm only interested in JavaScript file though, just so it's ready. So it has built me all the files. The JavaScript is 800 kilobytes, which is normal for 3JS projects because 3JS itself is like 500-600, and then a couple of other dependencies like gsub. So now let's try to run the template. I already downloaded to the folder 11T minimal, this same repository we are looking at. And to run it, you should just type 11T serve and you would immediately start a server. If you don't have 11T installed yet, you just need to go for the npx 11T serve or install it globally if you want to develop with it. So now we have the server running on the 8080 and we can look at it. So it's really that simple. So right now we see the localhost 8080 and we see 4 posts. And I can click on each of them. This is just the text and I can go back and this is just the text. But you can see that the URLs are being generated as well, the posts, a Bojack. So let's dig a little bit how the 11T CMS is working. I'm going to stop it for a moment. I'm going to open it again in the Visual Studio Code, just so we can see the structure of the project. So let's go bit by bit. First, we have markdown files, MD files. These are the content files where the content will be stored. I have only 2 types of them at this project: index MD, which is the home page content, like the the title that should be displayed at the home page, and some content on the home page, some text. And then there's the important bit is the layout. It means which HTML template this web page is going to be using. So 11t at start will be looking for all the markdown files, and if it finds one, then it will be looking for the template, and then it will render every single markdown file to some folder, to some HTML file in the end. And we can immediately see all the HTML files in the underscore site folder. Here we have the index.html and the posts folder, and then the folder for each of the posts. So it generates statically, which is the name of the 11t, is static site generator, generates statically website with all the needed web pages, even 404 page and favicon. Right, so that's how it works. Among those files, the most important one is also 11t.js, which is the settings of the build. It's like the configuration of the 11t build. It means like whether we need to copy this file to the site folder, because this file is only in the root folder, you could see favicon, but then it's being copied to the site folder as well. And then the fonts and etc. So if you need to copy JavaScript or CSS, we need to state it right here at pass-through copy. And then we have the styles, which is just the CSS from this template, and then the posts, which are I've already described. It's just the markdown files for each of the posts. And we have some attributes of the posts, like the date, title, some fields, and then the text field, like the biggest one is just the text. So we could populate these fields as many as we want, and then use them. And let's head to the last folder, one of the most important ones in 11t. This one is called includes, but you can call it whatever you want. These are the HTML templates of the actual build, like the HTML used to build the website. You could see that it's actually quite simple, and there are such tags, such template strings that you use to use some content coming from the markdown files. So these are the titles coming from there, and this is the home, this is a blog page, and then we have the content, which is the text, and then we have the title, which is the title, which we just saw in this markdown file. So this is the title, and this is the content. And then we have the home page, where we have the list, and because we have the posts.json file here, which states which posts we should display with which template, the 11t knows that we can loop through them for posts in collection posts. It's reversed, just so the last post is the first one, but we have this loop. It looks roughly like it's called liquid template, but also nunchucks. If you ever encountered the nunchucks template in Engine, it's also the same. They are the same family. So you would be familiar with those. So it's going to be loop 4 until the end 4. And we're going to create the list of those posts. So let's look again at the actual generation of the website. I need to run this one. Now we have the website, just a simple website with a list of the posts, and you click and you go to the posts. So this is roughly the same that we need to actually implement on our website. And let's do that. So we have the JavaScript in my HTML project. I generated the JavaScript. It's generated to the folder dist. So I can take this dist, the latest one, this one, and copy this one to the JavaScript. Going to be my dist. I'm just going to call this up.js. Then I need to copy the CSS as well, because I have the styles here, style CSS. I'm just going to delete all the previous styles and copy my style CSS. Now, because we need to copy these new files, new assets to the site folder, to the actual build, I need to change the 11t.js. And I just do the style and JS. Now, once I did that, I can already see the JavaScript folder in my site folder, and also the styles folder with my style CSS in my styles folder. Right, so everything is ready. The assets are being copied. I also created a couple of images, just the ones that are a bit more beautiful than the test texture, and I'm going to put them into the image folder in my CMS, in my static site generator. So I'm going to create the image, I'm gonna put them right there. And I will also add this folder. I will close for now the HTML, and I also add this folder to the copy, add through copy, add pass through copy. So now the image should appear here. It appeared immediately. So 11t re-renders, rebuilds the project once I change something while I'm in the surf mode. So now I need to use the HTML from my from the project that we actually built in here. So first of all, we'll start with the home page. I'm just gonna copy the whole HTML of the home page, go to the other project. So for now, we will be just working with the code. So I'm gonna open the home page liquid. I'm gonna copy the whole HTML right here. And let's change some bits. So first of all, the URL should be absolute. So we always link to the proper styles in JavaScript. Then the logo link should be probably just heading to the home page. And then we have a loop here. We have the item, 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 item. So let's change those items. We have two HTML pages now in this file. This is just the way to kind of merge them. So first of all, I can exchange also the title for the dynamic title, not the document, but the title. And then I will copy this loop, this whole loop copy into my file. So instead of these list items, I would need to generate these items from my HTML. And then I need to populate them with the actual data. Here, it's a bit more complicated example because they also have the external links posted. Like some posts are not actually posts on this website, but you navigate you to the other web page, external one. So I don't really need this if else. I only need this. So I have the post URL, which is going to be replaced here. I have the item. I have the post data title, which is my post data title right here. And also have an image and some description. And for now, I could leave it like that maybe, but I think it's better to at least switch it to one JPEG. And because the images are 1.5 to, I think the proper aspect ratio for the images is 1.5 to 1. I can do something like this just to make them bigger a little bit. So now we have the old project localhost, and now we hopefully should see something here on the home page. But I need to remove the old HTML because I still have two HTML pages in my file. This conversion process is always a bit dirty. So I'm going to remove this I don't need the post date. So there's going to be a loop, but with my HTML. And I can remove the old HTML completely. And now we immediately see that web page is actually working because we used the JavaScript and the images are static, but let's change that. So we have some markdown files. And as I mentioned, we miss the image and the description. So let's fix that. We have the posts. And I can do this. One JPEG. I named the images just 1, 2, 3, 4 JPEGs. I can just do this. And then description, just some lorem ipsum. So we have an image and description. Let's add these fields to every other post. It's gonna be 2 JPEG. Gonna be 3 JPEG. And then the last one is gonna be 4 JPEG. And let's add some text because the first one had some text and the title. At least one paragraph of text. So in Markdown, if you put this mark, it means it's the heading of the first level. So it's going to be H1. Right. So we have something. We are not outputting anything yet. So let's do that. We're going to go back to the homepage template. And instead of just one JPEG, I'm going to output post data image. And instead of description, I'm going to output description. I could see immediately that the text has changed. So we have the dynamic text now. The image has disappeared though. And that's because, let's just check them in the HTML. Maybe something is wrong. The images are empty, probably because I messed up somehow. So it's post data image. And we have them as an image. All right. Yeah. So now we have 4 different images already on my website. And if I click them, they're going to try to zoom in, but the second page is not yet implemented, so we can't see the result of the animation. That's where we need to implement the second page now, so the blog post liquid. Of course, it's not really a blog post, but we could rename those templates at any point. This template is really small compared to mine, so let's copy my template right here under the first one. I'm going to switch the URLs first. The JavaScript is linked. Probably you could use some other imports or includes for the header because the header is the same and the logo is the same. So we have the header, the logo, and then we could also use title here, just like they're using. And then what's left? What's left to use is the title. So instead of H1, which we have here, single content, we could actually use the title. Maybe I remove the link completely here. So it's going to be the title of the web page. And then we should also use the content. And the content is generated with the paragraphs and proper HTML. So you should just wrap it in a div. So all the stuff that I have here, like the figure and the rest, would be just replaced with the content. This should actually do the job. So let's see if everything is correct. Could remove the old template completely. Now we're looking at the web page. I'm zooming, something is still disappearing, and we see a black screen because I forgot to replace the texture linking from the CSS, from the inline CSS. And I can do that, changing the path here, and just using the data from the image, because we can use here just the content, the image, we don't have to reference from the post. And let's see what's going to happen. And we see the image and it's scrolling, we see some content of the web page. If I go back, see the curtain, I can scroll my projects. I think I still have some old HTML left in the home page. I replaced first item with a loop, but I still left the other ones here. Just remove them, a lot less HTML, and here we go. So we have the web page with the dynamic images coming from the markdown files. So it's almost like CMS, kind of like a simplest CMS possible. So you have to edit the text files to change something. And then when I click, I just zoom into the image and here we go. We can scroll it. It's all the custom scroll everywhere. And however I scroll the objects, I can just zoom any web page. I mean, it's not that beautiful. I'm not much of a designer, but I tried to make it a bit nicer so you could get a feeling of what you could achieve with that. So let's just recap what we just did. We started with an empty file, completely empty JavaScript and HTML file. We then implemented some JavaScript WebGL animations. We then merged them with some existing HTML, and that HTML could have been random, could have been any HTML. I didn't really use any of the CSS, something special, nothing like that. And then that HTML merged with WebGL, we tied down to the Netlify static site generator, which could be used with now any CMS or any software, or you just can edit the markdown files and immediately deploy the website. So now, whenever I edit something in my 11 minimal folder right now, in the folder website is a ready to deploy website. So you just upload these files to any file hosting and you have already working websites, complete and perfect. You could also implement a bit more advanced technique. You could push this one to repo And whenever you make a commit, there's going to be a hook which is going to update the actual live website. But that's going into the other direction, to the deployment techniques and so on, which you can learn in some other workshops. And hope you like that journey from the WebGL until the CMS, and using some math, using some shader effects and resizing. And of course, there's a lot to do still in this project to make it perfect, to make it award-winning. But I advise you to be creative and create your own effects and polish those, considering all the techniques that I described here. Hey, we just built the amazing website, well, simple but still amazing website with WebGL, Barber.js, shaders in a couple of hours. I hope you learned a lot along this journey, and I hope you will implement those effects. And I'm always eager to hear your feedback, like what I did wrong, what I could do better in my courses. This is my second course. I try to review all the feedback that I got from the first one and to improve it, to make it a bit better, to put more information into it, to review some build tools like the static site generators in the Barber.js, so you could be able to create a full ready for the upload website and even fill it with your content. So hope you like that. See you in the WebGL world.